Good morning, and thank you for being here today to honor the brave men and women who paid the ultimate sacrifice in the pursuit of space exploration. Today, we remember the Apollo 1, the Challenger STS-51L, and the Columbia STS-107 crews, and all other fallen members of the NASA family. Every now and then, it's important for us to step back and consider the vast scope of our work, to remind ourselves of what it really means to be in this business, where we do the impossible and break exploration barriers beyond Earth and towards the stars. We know and recognize that human spaceflight will always be filled with risk. For those of you like me who have been a part of Marshall Space Flight Center or NASA long enough, you've experienced both the ultimate joy of mission success and the tragic consequences of failure. Just like me, I'm sure you can remember where you were when you heard the news or read an article about these tragedies. Some of you may have even watched them on television. And afterwards, many of us worked together for the solutions to keep those bad days from happening again. Today marks the 35th anniversary of the Challenger accident. As we commemorate the 35th anniversary of losing Challenger, we pause and remember those crew members who have given their lives in pursuit of space exploration and discovery. They were our colleagues, our friends, and more. They were our NASA family. Challenger and Columbia were woven into our hearts, solemn reminders of what is at stake. They are why we are committed to vigilance and safety. With risk comes a responsibility to honor what we lost, but also learn from the mistakes of the past. One of my points of emphasis for the management team at Marshall is risk leadership, and that is because nothing worthwhile is accomplished without taking risk. It's our job at NASA to leap into the unknown of our mission of discovery. We must have the courage to jump, but first we must make the risk as small as possible, and then go forward. As we prepare for a new era of space exploration with the Space Launch System, now is the time to recommit ourselves to safety and excellence. We will never forget the courage it takes or the lives given in the name of space exploration. And we will carry the lessons of Apollo, Challenger, and Columbia with us as we design and build the SLS, the Human Landing System, and assist in NASA's Commercial Crew Program in order to fly again. We also want to remember many others who have dedicated their lives to space exploration and have passed away. We recognize their sacrifices and accomplishments, which have propelled us to where we are today. As part of today's program, we will have two guest speakers, astronaut Butch Wilmore, followed by our Safety and Mission Assurance Director, Bill Hill. Upon the conclusion of their remarks, we will view a presentation of those we've lost in the pursuit of space exploration. Thank you again for your interest in this important day. We must continue the legacy of those we've lost.
Good day. My name is Butch Wilmore. I've been an astronaut with NASA going back to 2000, so quite a few years. And this is a day every year that we remember. And we remember for good reason. Good reasons to recall back to some of the issues, the things that have taken place in the decades past. Specifically, we want to remember the names. We'll remember the people. Ed White, Virgil Gus Grissom, Roger Chaffee, the Apollo 1 astronauts, and of course the astronauts from Challenger, Dick Scobie, Michael Smith, Ellison Onizuka, Judith Resnick, Ronald McNair, Gregory Jarvis, and Krista McAuliffe. And from Columbia, back in 2003, we remember Rick Husband, Willie McCool, Laurel Clark, Kalpana Chawla, Michael Anderson, David Brown, Elon Ramon. And remember them for good reason. They bravely went forward into the unknown. An unknown that even now, after all 50 years of flying in space, humans in space, there's so many unknowns that lie just beyond our atmosphere. And we're still discovering and still exploring. And even now, as we seek to go deeper into space, than we've gone in decades with the Space Launch System and Orion, out to the vicinity of the moon and beyond, perhaps in the not too distant future. We always want to recall back from where we've been to where we are now and what has gotten us to this point. And these individuals, these names we just mentioned, are part of our family. They're part of the family that we've been ensconced with, and we work together with various NASA centers, and we do things that are very, very difficult. And they knew the challenges, they knew the difficulties that lie ahead, yet they went boldly forward anyway. Them and their families, they were passionate about their jobs, passionate about exploration, passionate about human spaceflight. And they went forward, again, knowing the risks. And they paid with their lives so that we could be here today, continuing to go forward for the right reasons, but reflecting back also for the right reasons. Lessons learned that we've incorporated into much that we've done over these decades, and we continue to do. We never forget, because remembering is vitally important. We remember that letting schedules push us forward and blindly forward is not the way we should go. I remember myself, dating back to when I was a fleet aviator doing flight tests, there was one specific thing that happened in my career I thought I'd share with you. This is a T-45 Goshawk, and I had the honor to do the initial flight test with this aircraft back in the early 90s. Did many things, many exciting things, including taking it to the ship for the very first time for its initial trials. And part of what we were doing, just to put it briefly, was the approach handling qualities and also minimum in-speed assessment for this aircraft. Every airplane that lands on an aircraft carrier has documented minimum in-speed, and that's with relation to how much wind is going over the aircraft as it hits the end of the aircraft carrier. So that is predicated on many things, but basically you want to have an in-speed that will give you no greater than 10 or so feet sink off the bow. So that is established in flight test. You can see here a picture on the catapult with the launch bar down, and this is what would sling the aircraft into the air. So just real briefly, just a quick video to show you that. So some carrier quals, it was long after I did the flight test, but just to show you T-45 launching off the carrier deck. Now you notice no sink off the bow there, plenty of wind over the aircraft as it lifts into the air. This next video shows, it's vintage, of course, you can see from the way it looks, but it shows an A6 intruder on a normal catapult launch on a deployment, and this intruder got what is called a cold catapult in the day. They're very, very, very uncommon. They were very uncommon then, but even more so uncommon now. But it did not get the force off the end of the stroke that was necessary to enable it to fly. So what happens is it goes down the stroke, and it doesn't have flying speed, so it sinks off the bow. The pilot pulls the nose up, it continues to sink, he puts his landing gear up, and eventually he does what we call pickles off his drop tank to try to make him less heavy, so reduce some weight. You see the drop tank pickle off, then the airplane ceases to fly and starts to depart flight, and they eject. Regrettably, the first person did not survive, and the second barely got a chute before he impacted the water, and he did survive. So this is obviously something that you would not want to happen, and this is part of what our minimum in-speed test is, to make sure something like this doesn't happen. So again, briefly, on the very first catapult launch, we're targeting 3 feet of sink off the bow of the aircraft carrier, and as I go down the stroke, because I'd done a lot of catapult launches leading up to this as we worked ourselves up, it was a lot less thrust or force than I expected for a 3-foot sink off the bow. And as I went to the end of the carrier, I sank more than 3 feet. I did not know how much at the time, but I knew it was an enormous amount of rate of descent. One hand on the stick and the other hand I had on the ejection handle, ready to pull it if it looked like I needed it. The airplane fortunately did continue to fly, however, and cleared the water barely and just began to climb out. So I came around, I landed on the aircraft carrier, and we did an assessment. Was it the catapult that had a problem? Was it the airplane that had a problem? What was the issue that caused this excessive sink off the bow, that unexpected sink off the bow? What caused it? So as we went through several days of iterations, the catapult was fine, the airplane was fine, and we determined that the engineers that had done the calculations for what was necessary to get a 3-foot sink off the bow had done the equivalent of transposing a fraction in their calculations. So one very, very small mistake caused this very big change, obviously, in the thrust of this catapult slinging this airplane off, and a very excessive sink off the bow. The aircraft carrier is 60 feet above the water, and it's surmised based on camera angles and whatnot that I was at least 16 feet from the water, if not closer. So again, it was a lack of attention to detail, going over their calculations, triple checking, making sure everything was good. But like I said, not even noticing the transposing of a fraction. Could have been a very bad day for me and for the program. Fortunately, like I said, it worked out okay. We learned from that and we go forward, and there are various ways that since that happened during that carrier qualification that the Navy goes through other stringent rules that have been incorporated to ensure that all calculations are correct. Of course, this was back before we had supercomputers. It was not back in the day of slide rules, but it was far back before we had a lot of ways to check it, which we do now. So I share that just as one example that I have had in my professional career, that looking back and assessing what has taken place before is very important. So today, we're under some very, very difficult circumstances. We don't even see each other face to face. We have very little interaction during these COVID timeframes. So I encourage you to continue to check the details on every aspect of what you do, because human spaceflight is vitally important for our nation and for our global community as we continue to explore and reach out and go beyond. So as you're sitting at home, or maybe occasionally you do come in, or wherever you are, do your work diligently, remembering the past, remembering those individuals whose names we mentioned earlier, and others that have gone before, because we are a team. Yes, the astronauts are the pink bodies that get to sit in the seat and enjoy the ride, though it's a very professional environment inside of a cockpit as you're on ascent, leaving the planet. But it's also a joy. We get to do those things, but it's the team going forward with our national goals that make this whole program work. So today, like we said, we look back and we do remember in this day of remembrance of those that have gone before us. Again, those names we mentioned and many more who have given their all, passionate about human spaceflight, passionate about what we do day in and day out. And it's my prayer that that is you as well. You continue your passion even in difficult circumstances as we go forward, because what we do is vitally important to us as a NASA community, to our nation, and to our world. Thank you.
Hi, I'm Bill Hill. I'm the Director for Safety and Mission Assurance here at the Marshall Space Flight Center. As we pause to reflect our past on this day of remembrance, I want to share a few thoughts with you. First and foremost, we must learn from our failures, especially the larger incidents that we've had, like Apollo, Challenger, and Columbia. Failure, for the most part, is an option. We have to fail to learn, and as long as we don't injure or have a death during the incident, it's all lessons learned. It's all good data. We need to push the envelope. We need to understand where the cliff is, and this helps us better understand what our systems can do as we test them on the ground, as we operate them in the air or in flight. It helps us reduce the unknown unknowns. Critical among the things we do is we must stay curious. Curiosity is one of those things that, if you hear something or see something that doesn't make sense, ask a question. Try to seek what's going on. And we must explain what's going on to better understand. It's key too that we don't forget that physics does not change. We cannot defy physics, and we must explain what we don't understand through the use of physics. Laws of physics are great for helping us do that. Our business is risky. We live in a risk-reward paradigm. Not the reward. If the reward is substantial, we might be willing to accept more risk as a nation and as an agency. And this is going to be critical as we push out into the solar system. Risk acceptance is left up to a few senior leaders in our agency. Not everyone has to personally accept the risk. I know a lot of people think that way, but there are only a few risk acceptors. Our job is to identify the risk, identify potential mitigations, quantify it if we can, and then present that to the senior leaders for decisions. I have been touched personally by all three major accidents that we've had. I came to NASA through a contractor that supported the Office of Safety and Mission Assurance in Washington after Challenger. I had the opportunity to go visit the Apollo 1 hardware at Langley and put hands on some of the hardware, gloved hands, to try to seek the answers to a question that we were asking me outside. And then after Columbia, I led the agency's return to flight activity to get us to the first mission, STS-114. I swore at the time I would do everything to make certain that we weren't stupid like we were in the days ahead of the Columbia launch. And when I say that, I mean it that, we just weren't listening. We weren't paying attention to the hardware. We weren't paying attention to the physics. In closing, I want you to keep in mind the families of our lost astronauts. They are as important as the astronauts. They carry the burden to move ahead with their lives without their loved ones. I had a good opportunity to meet with Mrs. Onizuko and Mrs. McNair, both wives of Challenger astronauts, and their jubilance and support for Columbia just kind of buoyed me and made me want to do better and made me want to seek how to better do safe space flight. I hope that you all reflect on what you've heard today from Jody and Butch and myself, and use this information to become better engineers, scientists, and technicians. Stay curious, ask questions, and continue to the best of your ability to support safe human spaceflight. Thank you.
Today is the annual Day of Remembrance, a day for the NASA family to come together to remember those who gave their lives in pursuit of exploration, knowledge, and a better future for humanity. We solemnly remember the crews of Apollo 1, Challenger, and Columbia, and all those who have lost their lives so others could reach the stars. Thank you. You will never be forgotten. Today, we remember the crew of Apollo 1. We also remember the crew of the Space Shuttle Challenger. We remember the crew of the Space Shuttle Columbia. We remember and honor all these brave women and men, along with all the others who dedicated their lives to the cause of exploration and discovery. Please join us for a moment of silence as we honor these fallen heroes and all members of the NASA family that have passed since the conception of NASA and in recent days. This concludes today's Day of Remembrance program from NASA's Marshall Space Flight Center. Thank you. Ad Astra.